Okay, so we are going to be talking about the Rutherford model of the atom. All right, so Ernest Rutherford, he is going to end up disproving Thomson's plum pudding model. And he does so by using his famous gold foil experiment, where alpha particles, which are positively charged, right? It's important that you know that the alpha particles are positively charged, and they're directed at gold foil. They should pass through with only a slight deflection due to some of the positive charge throughout the atom. So remember, our plum pudding model has positive and negative charge interspersed equal amounts inside this whole kind of like chocolate chip cookie plum pudding model. So he bombarded a very thin sheet of gold foil with a narrow beam of those positively charged alpha particles to see if the alpha particles pass all the way through. So here's a description and a pictorial diagram of the gold foil experiment. We have this alpha particle, right, positively charged rays, and what happened is most of the particles just go all the way right through, like a bowling ball. Throw at the wall, goes right through the wall. I mean, kind of a big deal if it goes through absolutely nothing to get there. So nothing happened to most of the particles. But some of the particles kind of get deflected at an angle. Some of them get deflected almost straight back to the source. So this leads to some very important results and some very important conclusions from those results. So the result is the majority of the particles went straight through the gold. Remember, these are positively charged particles. They just passed through. Some of the particles bounced off at that large angle, and some bounced back straight to the source. So this led to the conclusion that the atom is composed of mostly empty space, because most of the alpha particles went straight through with nothing happening. But the mass of the atom and all of the positive charge is centrally located within the nucleus of the atom, right? This is what we call the nucleus. So since some of those alpha particles got deflected or ricocheted backwards to the source, that indicates that they were positively charged, because like charges repel. Alpha charges are positive, the nucleus is positive. So this leads to Rutherford's atomic model, where we call this our first nuclear atom. This is our first atom that has the nucleus in the center. And the protons and the neutrons are located in the nucleus. The electrons are around the nucleus and occupy almost all of the volume, and the rest is empty space. So that leads us to no more plum pudding model. And now we have the nuclear atom, which leads us to now let's talk about the parts of the atom. So the atom is made up of protons, and this is the symbol of the proton. Your parts of the atom are also listed on table O of your reference tables. And the charge is a +1. So the bottom number on table O is a +1. So that means the charge is the bottom number on table O. And now located in the nucleus, right? Inside the nucleus is positive and has a mass of 1, which is our top number on table O. So then we go on, so we've got our proton inside the nucleus, making the nucleus positive. So now also in the nucleus, we have our our neutron, and that's our symbol for our neutron. Neutron has no charge, neutral, right? It starts with the same first 5 letters, neutral, not negative, neutral. Also located in the nucleus of the atom, also listed on table O. Still on table O, the top number is mass on table O, and the bottom number is charge. So 10N on table O, so it has a mass of 1. And notice it has a mass of 1 and 1.66, right? This is the same as mass as the proton. So same mass as a proton, right? So the same mass as a proton. And our last particle is the electron, which is our symbol E negative, which has a charge of -1, which is opposite of the proton, but in equal what we say magnitude. So it has an equal magnitude of charge, which is 1, but the opposite sign. It's located outside the nucleus, and the mass is essentially 0, or 1/1836, or 9.07 times 10 to the -28. So very small, we essentially say it's 0. So here is the electron, which on table O is going to be sometimes listed as the beta particle. The mass is the